Um, we're doing the electron chain, or the electron transport chain. Sorry, I'm a little nervous.
Relax.
Anyway, it's a series of protein complexes. They're better than the mitochondrial folds of mitochondria. Membranes, the cristae, yeah. So electrons are captured from donor molecules that are transformed through these complexes. It's an oxidative process, which means it's losing electrons, and well, not really losing. What they're doing is they're giving up their energy to pump hydrogen ions into the gradient in order to cause an oxidative process, which builds up over time on this end, over on this side, and then, well, she'll explain it to you when it gets to her part. But, so yeah, so I'm explaining the NADHQ reductase, or the dehydrogenase, and so. Okay, this is the NADH. This is the NADH that was created when the two electrons are removed from the pyruvate. So what happens is it pairs up. For each electron, there's a hydrogen, and it pairs up like this. And what happens is it enters the NADHQ dehydrogenase, and then two electrons are going to be passed, and the two electrons are going to be passed to the ubiquinone, which is Myra. And the two hydrogens that I'm losing that are being pumped up with the electrons, because the electrons are actually pumping the hydrogens up, so they're actually going to be like through. I wish I could put it through there, but my arm won't fit. But anyway, they go through and they go up and they end up in the gradient up here, and that's where, well, they're going to be like building up more power. So, but yeah, that's my part. I'm done.
And you put it in there? Oh, that one. And which is also called coenzyme Q, which carries electrons. Two electrons are passed from NADH into NADH dehydrogens, and it pumps hydrogen ions. And this is pretty much what I just do, and then I pass it on to this one right here. Which is her.
Which is me. I'm a big yellow tube. And what I do is I hold on to these, and I have a hydrogen. One hydrogen ion passes through here and assists one electron to go through here and go on to the cytochrome C. Because the cytochrome C, which is him, he comes in and he takes one at a time to bring it over, which is basically, after that goes through, this one comes up and goes through, and then it gets this new batch that happens.
As the electrons are transferred one at a time into cytochrome C, one hydrogen ion is pumped through cytochrome BC1. Four electrons are accurate in cytochrome oxidase. Electron react with a molecule oxygen molecule and 8 hydrogen ions. 4 electrons and 4 hydrogen ions molecule oxygen are used to form 2 water molecules.
Alright, so I'm this one, the cytochrome oxidase. So I wait for 4 electrons to come over here. Or I wait for 4 electrons to be transferred from the cytochrome C. And then the 4 electrons interact with molecular oxygen and 8 hydrogen ions. The electrons, oxygen, and hydrogen ions combine to form 2 water molecules, which you can see right here. I didn't have, an array of different things, so they all look the same, but they got little names. Okay, let's see. Combine to form 2 water molecules. The other 4 hydrogen ions are pumped across the membrane and over to the top. These hydrogen pumping steps create a gradient. The potential energy in this gradient is used by the ATP synthase to make ATP from ADP and inorganic phosphate.
Okay. So pretty much all of the hydrogen pumping that went on entered the the energy gradient up here. And I'm ATP synthesis, so what I do is, this little piece right here this is my rotator, right? This little piece. It was blue in the video if you guys remember. But this little thing is spinning, and for every single one of these that falls in there, these little hydrogen energy that falls in there, it takes 3, it accrues 3, and then it creates enough energy to synthesize what's actually floating along the bottom, which is ADP before it becomes ATP. So you have it just cruising along the bottom. And then it forms the energy, and then it actually, my little ball was supposed to come back out. And now it's down here, but it actually merges with this and becomes ADP, which I just lost. Or ADP, yeah, there you go. ADP. Sorry, ADP. That's pretty much the process.
Any questions for this group?
Great scenery. I really like that. Great
They
scenery.
had lots of nice background, yeah, definitely. It was very hard to show all